Hi everyone, it's Sam Atkinson from CoreJavaInterviewQuestions.com again with yet another coding example from an interview for you to practice before you go for yours. In this case, it's the palindrome detector. So a palindrome is where the first half of the letters match the second half. So for example, in the word civic, C-I-V-I-C, that is a palindrome because it's C-I and then a middle letter and then I-C. Same with race car and all those sort of sentences. So a classic test is to be able to check what is a palindrome. If I pass a string in, is that a palindrome? And what is the best way of solving this? Because there are loads of different ways of doing this I've seen with multiple collections and iterations and stuff. But I'm going to show you a nice one now that involves only iterating over half of the data set. So I've created here, again, a blank palindrome detector. So if I create a unit test for this, so the palindrome detector test. There's going to be a few edge cases for this. So one of the interesting things is that you should be, if you're interviewing, looking at the candidate to say, are they checking what the requirements are for this? So if you are the candidate, you want to be making sure you're saying things like, okay, if I'm passing empty string in, or if I'm passing one letter, like what's the deal, what's the rules? So let's just go through a few cases with this. So let's say detects that race car is race car backwards, which is the definition of a palindrome. So if we create a new palindrome detector, in fact, let's create a field for that so we don't have to keep doing it each time. And there we go, cool. So I want to do palindrome detector dot detect race car. Cool. So if I create a method for that, and it's going to be a boolean because it either is or is not a palindrome. String to check. There we go. So we now have a palindrome detector, and then we want to assert that race car is true. Now that reads terribly at the moment, so let me just change this so that it is, let's say, results. There we go, that's a bit better. Cool, okay. So that is our first test. Let's do a couple more though first. So with this first one, it's race car, it's got an uneven number of letters, so it has a special use case that you need to hit code with the E. So let's put another word. So let's say detects that toot is toot backwards. Okay, so with that one, sorry, I just noticed that that's changed it. So change that to toot. So that's, we're also expecting to be true. I'm also going to quickly check that a negative one. So detects that core Java interview questions is not a palindrome. Java interview. So that we are expecting to be false. And then we'll put the use cases I said at the beginning. So let's say that empty word is a palindrome. Again, it depends on your interviewer, but I'm going to go with this one. So we'll say that's true. And then we'll do one more, which is that we did that single letter is a palindrome. Now, there's tons of things that you can go on with this for this. So case insensitivity is the obvious one that you want to look for, special symbols. You can look after all those yourself. I just want to keep it relatively simple for now. So we have 5 good tests there. So let's run those and make sure some of them fail, because at the moment we're returning either true or false, so some of them are going to pass. Oh, there we go. So, oh, that says to me, yeah, so that's right. So we're filtering, we're returning true at the moment, so this one obviously comes back. So let's have a look at what the implementation is for this. So what we're looking for with a palindrome is to check that the first half and the second half are effectively identical but reversed. So this means we can do a single iteration through it if we use 2 pointers. So what do I mean by this? When we loop through, we take an index and say look at the first letter. So for race car that would be R. We can also look at the last letter by using the length of the string and taking I away from it. So that would be the last letter and they would both be R, so that's fine. Next iteration I would become 1, and we can keep going in, kind of sandwiching in to make sure that the letters all match. So let's see if we can do something with that. So if I'm going to iterate through, so I equals 0, I is to check dot length. I'm going to make that into a variable, in fact, because it's going to get used a fair amount. Cool, and then I++. So we are looping through the string. Nice and easy. So what we want to check then, as we go through, is if the first letter, so if we say to check dot char at 0 equals to check dot char at length, which we've already gathered, then minus I, oh sorry, not char at 0, that's just its first iteration, char at I here, length minus I, so remember strings are 0 indexed, so we have to do minus 1 here, so that's the length of the string, so for race car that's 7, minus I, first iteration will be 0, so that's 7, minus 1 is 6, that's the last letter in it. So if those are equal characters, then we're fine, and that's correct. So what we're looking for is the negation of this. So if we make that, if it's not the case, that means we have not got a palindrome, so we instantly want to return false. Okay, and then we can return true. So let's see how many of our tests have made pass after that. Great, so all the tests pass. That was a really easy piece of code for us to write, and it's nice and efficient, but we're not quite as efficient as we could be yet. At the moment, we iterate through for every single letter in the word. So for race car, that is 7 times. We don't actually need to do this though. We know that a palindrome is a palindrome after we've iterated through the first half of its letters. So for race car, we only need to do RAC to know that it's a palindrome, because we will have iterated through the last letters as well. And we know that because it's uneven, we don't need to worry about the middle letter. So we can make this a little bit more speedy by cutting out the loop sooner. So if at this point, we want to check if I is greater than the length over 2, then we can break. Now this isn't quite right. So the length over 2, so for a 7 letter, would be 3. However, we're 0 indexed, so we actually need to plus 1 onto here, or minus 1 onto length. And then it's actually equal or greater to. So greater than or equal to, there we go. So if we, just to prove my point here, so if we just system.out I, and then run, oh, this is going to run all of them, so let me just, there we go. So 0, 1, 2, so that's RAC, and we know at that point that we don't need to iterate any more letters. So this is absolutely correct. We have saved a lot of iteration, which if we were doing a giant palindrome, that would be a big deal. But more importantly, some interviewers are going to really care that you can get this as optimal as possible. So that is the best result the best implementation that I'm aware of. If you have a better one, or if you have any questions, or any questions you'd like to suggest that I go through, or anything like that, please contact me. You can get me on YouTube. You're even better if you head to the blog at corejavainterviewquestions.com, and I will answer anything that you send over to me. Thanks for spending the time to watch this, and I'll see you next time.